So I wanted to test the individual LEDs, and since I didn't have the proper power supply with configurable voltages, I had to make do with what I have. And over here I have a AA battery packs that I used. Right now I have two AA rechargeable batteries for a total voltage of 2.5 volts. So that's just barely enough voltages to turn on a single LED. But before we could test the LED, I took an X-Acto knife and scraped off the paint on the traces, like over here and over here. So let's see how bright the LED is with a 2 AA 2.5 volts. So that's not very bright. So that thing's only lighting up one LED, and the current is 1.61 milliamps. So now let's see how much brighter the LED gets when we use 3 AA batteries in this battery pack. So the total voltage is 3.8 volts. So now the LED is considerably brighter, and the current is now 138 milliamps. So using this computer power supply and jerry rigging this wiring using this floppy uh, connector, I used the leads from a cutoff from a resistor and just plugged it at the end like that using the 12-volt wires. And this is how I tested the each half strip using 12 volts. So I just touched the terminals in here, and that lights up the half a strip. So now I have the computer power supply connected to my multimeter, and the voltage is 12.5 volts. So let's measure the current when it lights up half a strip, which is 4 LEDs. So the current is 68 milliamps at 12 volts. So that's with 4 LEDs. Now let's go up one strip and measure half a strip with 5 LEDs. See that barely lights up. That's half a strip with 5 LEDs. And the current is showing only half a milliamp. So my power supply, my computer power supply is inadequate to test a full strip. It can barely light up half a strip with 5 LEDs. But it works. So I wired up this diode and resistor in replacement of the LED so that at least I could run this TV until I get the replacement LED. So the diode that I use has a forward voltage of 0.46 volts, and the resistor is a 10 ohm resistor. I believe that's a 5 watt resistor, so it's the bigger resistor. And I just connected the resistor and the diode in series to simulate an LED. It's not perfect, but it will do. And I just have to make sure that I turn down the LED, the backlight power, so that it doesn't burn up, because that LED, I mean that resistor, does get hot, extremely hot when it's on. And I'll wrap that in heat shrink to keep the heat off the white plastic diffuser so it doesn't melt it. If I remember correctly, I think the resistor that heated up to 60 degrees Celsius at I think at 30 level backlight, 30%. So it still gets pretty hot. So I have the TV up and running now thanks to the diode and resistor hack repair that I did. And I'm running a color background test right now to see, just to see how well the backlight is diffused. And I have a blue background, and you could clearly see right at the center where the missing LED is. And the backlight is set at level 30 so that it's not too overexposed. And this is a gray background. And around that black blob in the center, you could kind of see around it there are small hot spots, small white spots, and I think that that's where the LEDs are. And at those locations, those LEDs are running a bit hotter than the other ones. And then at the corner of the screen, you see black splotches as well, but those doesn't coincide with where the LEDs are. I think it's just the way the LEDs are diffused or not diffused. So you get unevenness in the backlight. So in the top left corner and the bottom left corner, you see a dark spot. Now this is the green background. So this is a nice test to see just how evenly the backlight is spread out. And I would say that this TV is not very good at diffusing the light evenly. And some colors are much better than others. The red, you can barely see any difference, minus the missing LED spot. And this is a white background, and you could clearly see how splotchy the entire screen is. But keep in mind, this is at level 30 backlight. So whatever that is, 30% or... and black background. And back to the blue.